So yes, once more, welcome everybody to Hexa-X-II 6G series workshop. We start with the opening by European Commission and 6GIA. So over to you, Agustin, from European Commission.
Thank you, Mikko. Good morning, everybody. Let me just try to share.
Slides can be seen, you can be seen and heard. The slide is not yet in the presentation mode. But,
Can you see my slides?
yes.
Into presentation mode. Okay, now full screen, I hope. Okay, good morning, everybody. Thank you. It's a pleasure to open this workshop of Hexa-X-II. I would like to introduce the workshop by providing some of the policy context and also some introduction to SNS JU and 6G research and innovation in Europe, of which Hexa-X-II is part. And when I say a policy context, well, as you know, there are policy developments and geopolitical aspects that are changing very quickly. So this picture that I'm trying to describe here is evolving quite quickly.
Sorry, Agustin. I can see the title slide, but I guess you are now referring to slide 2.
I just changed now.
Okay, maybe it takes time. Also, it's not in the presentation mode at the moment visible here. But,
okay, so I put it in presentation mode, but it doesn't work probably.
Anyway, now the second slide can be seen.
Yeah, I'll keep it in that mode here if you don't mind. I hope it's big enough.
Yes, it's possible to see.
Share again. Okay, if it's possible to see, I'll go ahead. I mean, let me start this presentation by making a point on something that's sometimes overlooked when talking about 6G research and policy debates in Europe and elsewhere, is that for 5G and for network technologies, Europe has a very important position, what I call here a shared leadership position, with, let's say, 2 of the 3 main players globally, and a very interesting ecosystem and very active research and innovation communities here. So this is a starting base that we're building on with SNS JU and 6G research and innovation in Europe to be able to translate and to advance this position to 6G and future network technologies. Okay, hope you see it. The next slide.
Yes.
There's a history of 5G and 6G research and innovation in Europe. This started by the 5G PPP, also a joint project by the private sector and the European Commission, and where Hexa-X flagship also started. And now we took since 2021 to SNS JU, where we have a European 6G research and innovation initiative. As you see here in the slide, it is not only about 6G research and innovation, but also SNS JU has, the Smart Networks and Services Joint Undertaking has a task to accelerate 5G deployment and to coordinate 5G deployments in Europe in close interaction with the Connecting Europe facility, SEF Digital. In addition to this, and although this is not, let's say, part of the legal mandate of SNS JU, I should say that in the context of the strategic working groups of the joint undertaking, concretely the policy working group, we're also looking at further implications and synergies, in particular at the role for implementing the 3 Cs, connected collaborative computing vision laid out in the Commission white paper of February last year. Let me also mention that SNS is also very important for coordinating with member state initiatives and also as a vehicle for European and international cooperation and standardization. Now moving to 6G and why it is important, I think you might have seen this slide in other presentations, and almost everyone discussing 6G at some point talks about this. But I think it should be quite present, because I very often get the question about what 6G for, and also very vocal industry players saying, well, we don't want 6G yet. So I think we should all be active in communicating the importance of 6G and network technologies going forward. So as any other generation, it has improvement, performance-related improvement, like a higher capacity, connection density, and lower latency, but also as new elements, and those are shown here, such as the inclusion of AI, energy efficiency, openness for interfaces, sensing, and integration with non-terrestrial networks. So it is quite important to have in mind the new elements and the importance of 6G going forward. Of course, all these elements are not just for the sake of themselves. They should enable new use cases and new business cases as I show here, virtual, physical, and human worlds. And here it's some of the use cases of Hexa-X, collaborative robots, physical awareness, digital twins, and others. And these are in particular what 6G will be used for. At this point, of course, and this is the very important role of Hexa-X-II, is to describe those scenarios, the technical requirements for them, and the constraints. But this is, and of course, some of them might not be true, might not come true in the future. But it is very important to keep them in mind when doing research on 6G and asking ourselves the question, what 6G will be for. Let me also mention a few words about ITUR and 3GPP standardization timelines. And this, which I'm showing here, as you see, we're now starting, let's say, the pre-standardization phase. And in this case, the role of Hexa-X-II it's very, very important. And it's also a broader mission of SNS JU projects to have an outcome, an impact on the standardization. And there, the timing, it's as I said, very important, although these projects should feed into that process. As I said, that's going to start, or is already starting, going to start very soon. So I would call for this, of course, this Hexa-X-II project is part of its own mission, but other SNS JU projects should have this very deep in mind to cooperate and to provide an impact on 6G standardization. When we talk about 6G, we also talk about values, and this discussion on key value indicators is really important, linked to standardization. Here I only focus on sustainability, all the three sorts of sustainability, and also the dual role of 6G in that vision. It's about keeping 6G sustainable and minimizing the impact or the footprint of this technology, but also think of new cases for using 6G for further sustainability. And I know the second one is sometimes the most difficult, also the most difficult to show the results that are there. But that's one example of the positive impact on society that 6G technology can have, and should be part of these values and key value indicators feeding into 6G standardization. Let me now finalize by this slide. It's about another value or another political context of what we are playing in. It's cybersecurity and economic security. As you can see here, I'm summarizing the developments on high-risk vendors, 5G security, and the broader European economic security strategy that was presented back in June. Here, there is quite a focus on ensuring economic security in Europe. And therefore, there were a couple of measures published in January last year about different initiatives to ensure and to improve economic security in Europe. And that, of course, covers 5G and 6G technologies. As you can see, there are measures on foreign direct investment, outbound investment, also research and development security. This slide is not fully up to date. Here, I should also mention the very strong focus that the European Commission is putting on implementing and reflecting these economic security measures in the research and innovation programs. And there I should mention the amendment of the general annexes back in April to have an additional restriction for high-risk vendors. And I also should mention the focus of the new Commission on cybersecurity, economic security, defense, and internal security. And if you look at the planned points of the Commission, of the College of the European Commission, there are forthcoming Commission initiatives that will be that are planned for the near future. And there I should mention the white paper on the future of defense, of European defense, the new European internal security strategy, and the EU preparedness union strategy. There, 6G and network technologies can or may play an important role. And there, I would like to convey the increasing importance of security in the broad sense, being economic security, internal security, and so forth, when talking about cutting-edge technologies such as 6G. And I'll leave it there. Thank you, Mikko, and invitees to this workshop, and I wish you a successful workshop. Thank you.
Thank you very much, Agustin. And then we move to 6G-IA. So, Colin, please.
Thank you, Mikko. So I just want to spend a few minutes introducing from the private side. So as I'm sure you're aware, this whole SNS JU, which is the research program which sits behind Hexa-X-II, is jointly run by the European Commission and the private side. And the private side is represented by this association, the 6G-IA. And relative to this association, we like to try and be the voice of European industry. And I just wanted one slide to show that we are continually growing, which I think shows the strength of the European ecosystem on 6G research, but also the interest. And you'll see that we also have members from many different stakeholders. So this isn't just about the big telecoms players. We've got the SMEs, the verticals, the research institutes, the academics, all within the same association, trying to drive this SNS JU in the right direction. So what I'd like to do is, Agustin has kindly given the policy context, which is obviously very important. Let me just spend a couple of minutes looking a little bit more about the SNS JU and exactly where we are with that. So far we've had 3 calls in the SNS JU, somewhere around 80 funded projects and nearly 500 million euros of public money invested. So a sizable investment. We have had a lot of organizations involved. So 1,200 different entities have been funded. And I think the important things to look at here are also the last 2 numbers. So having 25%, over 25% SME participation in these projects. And this is vital as we try and build the future industries for Europe. And also having 33 participating countries is an impressive number, trying to show the importance of not just national research, but collaboration across countries and regions. We want one global 6G standard. And clearly having more participating countries is a good way of getting common ideas of what 6G should be. The sort of overarching targets that we're looking for, the sort of driver for the whole SNS JU in many ways, and indeed 6G research, is the requirements coming out of the IMT 2030 and ITU. So this defines what a 6G technology will be. or is defining, shall we say. And we can see that if we take the high-level overview coming from ITU, we can map those areas that we've funded within SNS JU to those particular areas that we've done on this screen. Now, forgive me, the writing's quite small, but we will share the slides afterwards. But the key point is trying to say the areas we're looking at aren't picked from pure air. They're not just things we quite like looking at. They are formed from the opinion of European industry, driven by the 6GIA, and from what is coming from IMT 2030 from ITU. If we look a little bit closer at the first call, so this is just giving a representation of that first 35 projects from phase one. What we try to do is we try to look at the areas that are being considered in those individual projects. So here's a list of all the projects, and these sort of horizontal bars are giving the various streams. And you'll see there is a broad coverage of many key areas there. And a particular note is perhaps on the right-hand side of that, this Hexa-X-II flagship, what is driving this workshop today. And you'll see that this is a clear flagship, which is meant to bring the work of the others together. And as you'll see over the next couple of days, defining the roadmap for 6G and 6G standardization. And you'll see the large number of dots next to it showing the broad areas that it has been covering. Beyond the projects, the SNS JU isn't just about research projects. And there are a number of other things which have been created and are maybe of interest. So we have the annual questionnaire, which gives us an insight into what industry is thinking on key aspects. We have the vertical engagement trackers, where we can see which vertical organizations are being involved and what they see as the key use cases. The standards tracker that tries to give an insight into what's going on through GBP and other standardization fora that are critical for the SNS JU community. And the trials and pilots brochure, which tries to give an insight into the key trials and pilots going on in SNS JU. We also have a number of white papers that have been created, some of them very influential. The one on the right there, the joint one we have done with Next Year Alliance, aligning the views on 6G architecture between the US and Europe, for example, has been quite influential on setting policy both sides of the Atlantic of what we should be researching into. So that's sort of a brief overview of the key sort of things that have been going on in the SNS JU up till now. Let me leave you with just two last thoughts. The first one is looking forward. So this is the next SNS JU call. Now, this isn't open yet, but it gives a sort of overview of the key areas we're intending to fund. So the key point is the funding will continue. We see continued requirements for cutting edge research in Stream B. And we see the need for building more experimental platforms and large scale trials as we try and put the pieces together in 6G technology and move towards optimization and development. And as a last thought, one of the other things that we have been involved in with one of the support actions is looking at the use cases around the world. So not just looking at Europe, but looking across the world. Where do they see the key areas and key technologies that should be covered by 6G? And this is just a diagram sort of giving a quick overview of where that is. And again, trying to emphasize that we need to target a global standard. That means we need to take into account the opinions and the views of the rest of the world. This will not be a European standard. This needs to be a world standard. And that's why it's excellent seeing in the agenda today the views from other parts of the world, other key regions. We need to come together and we need to get to some agreement about what are the areas we need to prioritize. What should the first release of 6G contain? With that, Thank you very much for your time. I hope that's been of interest, and I wish every success for the workshop today.
Thank you very much, Colin. And for any of the interaction, the chat is the preferred channel, so please use that one. And then depending a bit on the timing, so we might also be able to take some audio questions. But in the interest of time, I would propose to move to the next section. So thanks a lot again to European Commission, Agustin, and CICTMobile, Colin. So then let's move to the hosting project. So I have had the pleasure of being the overall lead for Hexa-X and Hexa-X-II, and we'll be going through some really basics of the project and where we are currently in the project, just to make sure that everybody has the background also clear and where we are right now. And then the later presentations will go certainly much more in depth about where we are. So let me start sharing my slides, and then also to add about my background. So I'm Mikko Uusitalo, and coming from Nokia Bell Labs Finland, and as said, had the pleasure to be the overall lead for Hexa-X and Hexa-X-II. So as you already heard from the previous presentations, we are the European level 6G flagship and funded by Horizon Europe, this Smart Networks and Services joint undertaking. Nokia overall leader, Ericsson as a technical manager, and the consortium is really widely covering the different parts of the value chain that I think many of you are already quite well aware. You also already in the very first part heard talking about the sustainability, and of course looking to the future, this is something that we need to stress and put focus on for any future development. And here also we need to note that sustainability needs to be understood really widely. In the 6G activities around the world, like energy consumption and to some degree carbon gas reduction is being taken into account. But then we also have been willing to and want to communicate this more wider look at the sustainability. So we have been looking, in addition to environmental sustainability, also the social and economic sustainability. And for example, on those you will hear more from the Work Package 1 presentation in this session. And we have been looking at these use cases last year when 3GPP started to work in this domain. So then we joined forces with other European actors, and then the input from Hexa-X-II on the use cases was an important starting point for interactive with other projects with national activities coordinated by SNS project. Then we have been looking at the technology development, and especially then how the bits and pieces fit together, how are we prioritizing them, the system blueprint on which we will also have a presentation in these sessions, so today afternoon. And then coordinating and interacting with the other activities, especially Europe, but also internationally. And this is just showing the different kind of strands there are where we have been interacting and looking at this 6G from this holistic system point of view. So in the work, Orange has been leading this Work Package 1, setting the starting point, 6G values and requirements. Nokia has been leading the end-to-end system part that is then putting the pieces together and putting this overall view. Ericsson leading architecture design, also building this overview from the architecture point of view. And then the technology-oriented work packages, Radio Evolution Innovation led by TU Dresden and University of Oulu, Future Devices, Flexible Infrastructure led by IMEC, and Smart Network Management led by Atos. And then this being supported by Work Package 7, Impact and Dissemination led by Telecom Italia. In addition to doing the technical work in simulations, in theoretical paperwork, so we are also building many elements of this, and we have come every summer at each EU CNC, we have come with set of demonstrations, proof of concepts to prove our points in the various tracks. And the final set of the demonstrations, we are targeting to have 10 proof of concepts ready this year, early summer at EUCNC in Poland, beginning of June. We are also sharing these demos via our YouTube channel. And this shows the current set of material available from our website. So analysis on these use cases, related requirements, analyzing these different sustainability points of view, and we are happy releasing every half a year new input on this end-to-end system view. And then there is latest material on architecture, radio enablers, this devices, infrastructure, and smart network management framework. And in all of these fronts now, as we are having the final sprint until June and all the way to early July, we will be releasing then the final deliverables. And already now, beginning of March, we will be releasing in these technical enabler areas then final deliverables. And you will now get from the technical manager, Patrik, you will get a snapshot on what there is to come to be released beginning of March, and then also more during these workshop sessions today and tomorrow. So handing over to you, Patrik.
Thank you, Mikko. I'll start sharing my screen. So my name is Patrik Rugeland from Ericsson Research and Technical Manager in Hexa-X. And as Mikko said, I will give a very brief overview of the deliverables that are being released in the coming months. The first one is from Work Packet 1 on 6G values, requirements, and ecosystem. And the deliverable will outline the final view on the use cases, the requirements, and the impact on sustainability from these 6 use case families with a representative use case from each. In addition, the deliverable goes through a stakeholder survey, an analysis of different potential stakeholders in 6G, looking at how the industry will and different users will interact with 6G. And finally, it will also outline this value creation process, where it's trying to look at how these key values that the Hexa-X and Hexa-X-II has strongly been working on can be evaluated and be how the value can be created through the use cases and through the technologies to analyze the benefits of 6G. The other deliverable is from Work Packet 2, looking at the final overall 6G system design. And the deliverable will outline a few end-to-end components, for instance, radio interface and protocols. A few aspects here is the improved MAC retransmissions or enhanced random access-less handover. There's also work looking at integrating intent-based service management, how this would look like to integrate this intent into the control of the network, and what different interfaces are needed. Security is, of course, also an end-to-end aspect that needs to be considered. And here we have a few works on, for instance, the physical layer security with some experimental measurements, or simulations on end-to-end resilience in integrating redundancy in the network. The deliverable also explores different complementary enablers from outside Work Packet and from outside Hexa-X-II. Since we are aiming to define an overall 6G system, we need to consider all potential enablers. So we evaluated around 40 different enablers from the rest of the project. And we also looked at enablers from other SNS JU projects. So incorporating 17 enablers from 9 other projects that complement the work that Hexa-X-II is doing. And putting this all together, we define the architecture for the end-to-end system. And instead of having just a simple overview of the whole system, we dive into specific views of these. For instance, looking at the end-to-end architecture from a radio protocols point of view, or for service exposure, or integrating towards multi-stakeholder. We're looking at these different pervasive functionalities, such as AI or security, how these would interact. And as Mikko said, we have the proof of concepts. The third iteration will be ready by EU CNC this summer, and we have the final deliverable in June, D2.6, which will outline this system proof of concept. Next, we have work packet 3, working on the architectural framework. And a few of the aspects looking at here is the architecture for different novel services, for instance, integrating machine learning operations, how to design the architecture for joint communication sensing, or compute offloading, looking at what different functions and interfaces would be needed. For the flexible topologies, aiming for increasing the coverage, we have some work looking at evaluating the coverage when you integrate both terrestrial and non-terrestrial networks to see where you have coverage gaps. And in more dense areas, looking at how different options for multi-connectivity or improving the carriagation from 5G can improve the coverage. Another important aspect is, of course, the migration from 5G to 6G. And here we are looking at different views of the overall architecture, how to integrate the 6G RAN with the core network that will be an evolved 5G core, but also how we can reuse the spectrum from 5G with this multi-rat spectrum sharing, so you can dynamically reallocate spectrum from different frequencies, different generations. For the orchestration, we are looking at the architecture of orchestrating in a cloud continuum where you have different resources in different parts of the cloud or even out in the edge. And some view on looking at how we can create this intent-based control by improving the network slicing from 5G. And looking at improving the efficiency of network, we have been looking at this modularization to have, for instance, a service-based architecture based on a data-centric view. We're improving the performance of the user plane function by making it modular, so you only have the functionality needed for a specific service or use case. Next, we have the work packet working on radio technologies and radio solutions. And here there's been many different works on different concepts. For instance, doing channel modeling in high frequencies, both millimeter wave and sub-terahertz. Looking at measurements for joint communication sensing and developing different concepts here. Looking at monostatic, multistatic, or bistatic sensing. And also looking at how we can use this 5G components with OFDM-based sensing. For MIMO, there's been many different evaluations. Looking at, for instance, coherent joint transmission, using DMIMO for JCast, or looking at simplified MIMO with this single bit converters. There's also been a lot of evaluation of these reconfigurable intelligent surfaces. Look at the performance of them and different deployment options. For the waveforms, there's been work looking at the 5G waveforms, how they perform at high frequencies, but also work trying to introduce new waveforms and looking at how they perform, seeing some benefits in particular at high frequencies. For the flexible spectrum access, there's work looking at spectrum sharing, for instance, between terrestrial and non-terrestrial networks, but also evaluations on this multi-rat spectrum sharing that we are looking at from an architecture point of view in the other work packet. And finally, AI and ML, which is a very hot topic. We have a lot of work looking at how this can be employed on the air interface. For instance, improving the CSI compression or prediction, or to compensate different non-linearities in the hardware. Next work packet is work packet 5, looking at devices and infrastructure. And one aspect of this deliverable is an update on the device classes we presented in a previous deliverable, looking more into details on the exact requirements here. there's also a lot of work on different transceivers, both in the sub-terahertz range and the lower frequencies, both doing simulations, evaluations, but also building these devices and testing them. And there's also a lot of work looking at system on a chip, how to build the architecture for this hardware accelerator integration, and doing a state-of-the-art analysis of different components there are. There's also work on these ultra-low power devices, so zero-energy devices or energy-neutral devices, where there's the building several different prototypes and measuring how they perform, where you can have wireless power transfer on the radio frequencies. But there's also work looking at improving the protocols, see how the devices can operate with extremely low power. So what are the actual functionalities, the minimum number of functionalities needed for these devices? And within this work packet, there are several proof of concepts. One aspect is this scalable extended reality, where you can dynamically shift processing from the device to the network, or some proof of concept using these zero-energy devices, using, for instance, the backscattered cellular signals for doing indoor positioning with these devices. And finally, we had the work packet looking at the smart network management. And we have developed a framework for different aspects of this smart network management. So there are many different enablers. For instance, these overall functionalities we see on top, looking at different aspects that are needed to monitor the whole system. So you can have monitoring telemetry or coordination of different closed loops, or managing the trust within the network. There are also several different solutions that cover the entire MNO system. For instance, orchestrating multiple agents when you have multiple clusters, or if you have distributed orchestration systems. And there are also many different specific enablers looking at specific systems. For instance, how you can have third-party resource control separation, so you can allow a third party to control part of the network. Or how you can monitor and control the creation mechanism for the network digital twins. Or how you can have introduced programmability in different parts of the network. On top of that, there are many different algorithms for this management orchestration introduced. For instance, looking at the AI-based controls for intent-based management, or you have federated learning in a multi-domain. But please look out for these deliverables that you will find on the Hexa-X website in the coming months. So thank you all for your attention.
Thank you, Patrik. Yeah, let's all actively use the chat for any questions and commenting as has been going on. And now we are at the moment when also the next presentation should start from the timing perspective. So then we go further in depth in drivers for 6G and update on key value indicators, important concept brought up by the Hexa projects. And this is going more in depth of the work package 1 of Hexa-X-II, which is led by Stefan Wendt. Unfortunately could not join us today, but it's great that we have CICTMobile here from TNO telling us about this. So CICTMobile, please, the floor is yours.
Hello. Shall I share the screen or?
Yes, please.
Okay. Give me just 1 second. Can you see the screen?
Yes.
Great. Perfect. So, hi everybody. My name is Cristóbal Vinagre, and I'm leading the task within Hexa on use cases and requirements. So we have already many workshops and presentations which expand on the work that we're done on use cases, the ecosystem, business models. So the idea for today is not to go over in too many details on that, but rather, as Mikko just said, expand on the process of the value creation that we've devised. But first, I'll start, let's say, with a quick reminder on our main goals and the set of use cases. So first of all, the primary aim of Hexa is to design a sustainable 6G platform which can maximize the overall value that it's delivering. So this slide here basically broadly reflects all the different working groups within Work Package 1 and towards what we have been working for. And in a nutshell, I mean, to design a technology that is sustainable, we must center the work around the 3 pillars of sustainability. This is environmental, economic, and social. As a second step, we must consider both scopes, which here are being phrased as this duality. So this means that first, the impact obviously must start at home. So we aim at making 6G itself sustainable. So there you can think of, let's say, how can you improve things in terms of energy consumption, in which materials you're using, whether the technology is affordable, is profitable, and so on. But also from an enabling perspective, which is the 6G for sustainability, meaning how 6G can enable other industries, sectors, and people to become more sustainable. Then to ground all of these, let's say, nice aspects and desires, we obviously need a vessel. And therefore, most of the work that we've done is based on use cases. As might not come as a surprise to you, use cases are extremely helpful in portraying how the technology will be used in the future. And with them, we can work on extracting the technical requirements, the KPIs, but as well, and this is a bit of the new approach, targeting key values and key value indicators. Lastly, within Hexa, we've worked not only on the technical aspects of the use cases, but also incorporating the ecosystem perspectives, which includes the business and revenue models, stakeholder identification, but also taking into account the societal views, the needs and concerns, let's say, regarding the deployment of 6G. So in a nutshell, we've been working on portraying how the technology will be used in the 6G era, what requirements and KPIs are needed, I mean, to make that a reality, but also thinking about the larger impact that 6G has in the society, environment, and economy. So next, as a quick summary on the work done on use cases, for those of you who are not yet familiarized with this, here is a list of the 20 use cases that have been developed within Hexa-X-II, and then based on a series of commonalities, which industries are these use cases targeting, what's the main aim of the use case, what are the main capabilities that are required, and so on. They were grouped into the 6 use case families, which are depicted by the different colors in this figure, to then select one use case which best represented the key aspects of that family and was called the representative use case. Why am I saying this? Because I mean, all of this work that we've done around use cases have been focused on these 6 use cases. However, if you do want to see more details on this, they can be found in our previous deliverable, D1.2, but soon in the final deliverable, which is D1.4, which will be submitted at the end of April. So, yeah, very, very much looking forward for that. So then, to do a brief reminder of the process, and this is, let's say, the slide that Patrik just showed a few minutes ago. This diagram shows the steps on our value creation methodology. So first of all, we have, let's say, 2 main alternatives. First, on the top left-hand side of the screen, this should be the should-be situation if our goal is to create value. So it's starting from the human and planetary goals to then design a use case that target that or those particular needs. So it's basically designing a use case to provide a solution or aid to a particular high-level goal. However, the usual situation is creating a use case because it responds to a business need or an opportunity. So then if you want to maximize the value, that first step in this process is to link this use case already to that set of human and planetary goals and think of ways in which the use case can contribute or influence them. Then, of course, as a next step, we have the description of the use case, what this use case is about, what are the main problems that need to be solved, or what are the main challenges that the use case is bringing, and then why 6G is needed, why cannot be done right now with current technology standards. In another, let's say, key important part at this stage considers the survey and feedback from external stakeholders, and considering how does this affect these definitions. So then we've arrived at a key step in this process, which is the first iteration of the sustainability analysis, out of which the initial key values are drawn. So this is done by thinking what are the potential effects that this use case will have on the ecosystem, both positive, and we've called them handprints, or negative, called footprints, on each of the three sustainability pillars. So these are what we call key values, and you might have guessed that these are a subset of these initial human and planetary goals, but applied to the particularities of the use case. Then, as the next step on the process, we have these three main dimensions, which are highlighted in blue. So first of all, we have the technical evaluation, which is thinking, how can we make this use case a reality? So obviously this involves defining the technical requirements together with many key performance indicators that this use case is targeting, which at hand it's essential input for the technical groups into achieving these requirements and consequently making these use cases a reality. On the middle side of this, let's say, square, we have the business evaluation, which is also critical for the success of a use case. So this relates to identifying which stakeholders will be impacted by the application and how. What are the main business opportunities around these use cases? What are the business models that make sense with it, with this ecosystem, and so on. And then the third dimension, we have the sustainability evaluation, which as a first step, given that we already have more and better information, these initial KVs can be refined, and obviously additional ones can be included. Also, some additional work that we've done is, for example, performing an impact assessment on these key values to determine how impactful can one particular key value be, and so highlight where we should pay more attention to. And lastly, all of this can also be complemented by the identification of the risks and challenges of the deployment of the use case, but also coming up with mitigation strategies for those risks and challenges that are not trivial or are, let's say, not easily manageable. So then once we have a refined version of these key values, we can work on deriving indicators. So that is, put into very simple terms, finding ways to measure either directly or indirectly the key value. And this exercise is repeated one by one for all the KVs in all the three sustainability pillars. So once this is done, we take a look at the indicators, and we notice that these KVIs can be very different in nature. And this is where the concept of use case KVI and enabler KVI comes in. The first one, the use case KVI, being, let's say, it's an indicator used to measure the success, value, or the overall impact of the use case, and can be therefore thought of as something, let's say, much broader that goes well beyond the scope of 6G. So if we are deploying, for example, a use case that is targeting a school, for example, you can measure how well are kids performing in school being aided by these, let's say, technologies. But of course, this is further beyond what is within our control. In this case, we have the enabler KVI that is much more, let's say, within our realm, and it's an indicator to assess the value or the impact of the technical enabler, or in other words, the technological aspects that enable the delivery of a use case. So as the next step, these enabler KVIs can be classified into indicators that are already being mapped to existing KPIs. So you can think of coverage, for example, other mapping to new KPIs, so energy efficiency, for example, and others that are not currently mapping to any KPI. So you can think of privacy or security aspects. So as a final part of this process and expanding beyond the scope of Hexa comes the application of the use case in a real life scenario. So in order to measure how much value has a use case or a solution brought to the system, you obviously need a target and you need a baseline. These baseline and targets are, let's say, extremely dependent on the context. Of course, it's not the same to deploy a use case in an urban or rural scenario, in a developing or developed country. So that is why I'm saying that it should be defined per application of the solution. So, and then once you're able, once you have been able to define a target value and a baseline, you can start this iterative process of finding that right balance between the different KPIs, requirements, and whether the value can be maximized or not. So as a final step in this process, we need to assess whether this balance that I was just talking about was achieved or not. So if it was achieved, okay, great. This use case is definitely creating some value, amazing. But if not, then we might have to reach for other solutions, such as redefining the use case or reformulate the priorities, the targets, and so on. I hope that was a bit clear. But now to do, let's say, a quick overview on the goals. First of all, we're very, let's say, convinced that the new technology should support a more sustainable future. And as I've mentioned a few times already, we've defined a list of 15 human and planetary goals, which have been derived from the sustainability focus areas from previous deliverables. Here are mentioned D1.1 and D1.2. And obviously, we were engaged in very thorough discussions on coming up with this list, and they have also been linked to the United Nations Sustainable Development Goals. I'm going to skip this because I've basically already explained this. It's a bit more on the process. But then the main idea for today was, apart from, let's say, giving an refreshing, let's say, the methodology to use one use case as an example, so you have a better understanding of what we mean by this. So first of all, we have this use case, the collaborative robots. The use case family, which is called collaborative robots, and you have the representative use case, which is cooperating mobile robots. So in a nutshell, as the name suggests, this use case portrays autonomous robots with the ability to move, to sense their environment, and being able to cooperate with other machines, but as well with humans to perform a given task. So here we describe a few example scenarios portraying how the technology will be used, how we're envisioning this use case to be a reality. So for example, cooperating, caring with robots, where two robots are able to communicate and to coordinate step by step to carry a large item. Another example refers to robots being able to quickly adapt to the needs of the market and produce products in a lot size 1. Then we have listed as well what are the main problems to be solved and challenges, which can be, let's say, challenging for the industry, for businesses, or they can be purely technical challenges. And then, as another part of the process, as I've already mentioned, we need to define why 6G is really needed for the delivery of this use case. And in this case, we're mentioning that 5G ultra-reliable low-latency communications does not meet the latency, reliability, and scalability requirements in demanding scenarios, but also pointing at the new demands for support on the network side, which are triggered by AI and ML. So then we describe the main technical requirements, which I don't want to expand much on this, as this presentation is not precisely about these technical aspects, but to highlight a few of them: local ad hoc connectivity, benefiting from the possibility of robots communicating together directly, leading to the creation of subnetworks. Then, of course, we have the, let's say, this extremely reliable low latency communication requirements, as I've already explained. And on the right-hand side of this slide, you can see all the main KPIs identified for this use case. So this leads me to what I think it's the most relevant part for this presentation at this moment. So here you can see already an extract of this list of the human and planetary goals, which here are only related to the environmental sustainability, but this is only because, let's say, for means of the presentation. So here you can see a few of what we've defined as human and planetary goals and what SDGs are related to this. And this is exactly what triggers the value creation process. So for example, we can think of how does the application of this collaborative robots use case has an impact on waste generation, both in a positive and negative way. So then from this, we can come up with specific actions per pillar, so in the environmental, social, and economic, in which this use case is having both a positive or a handprint or a negative or footprint impact. So to name a few, for example, we do consider from an environmental perspective and a benefit that the application of cobots will have an effect on an increased efficiency in the production processes. And that can mean both in, let's say, in the energy reduction and using less material, in creating less waste, for example, but as well, when we think of the footprints, obviously the deployment of any use case will require hardware, will require energy. So those are also footprints that we need to find ways to try to minimize those and to mitigate those impacts. Then out of these key values, that is basically all of these that I've already listed, and this is just a sample, keep that in mind. We have the task to try to measure what this key value is bringing, and this can be either directly or indirectly. And I'll just come to the last slide because here's basically summarizing all this information that I've already shown. So as an example, if we go over to the first one, resource efficiency, in which functionalities may be provided with machines with less materials, energy, and waste generated, we're talking about resource efficiency related to waste, energy, material use. And so likely ways to measure this particular key value are through the overall footprint of all the materials involved in the production processes. And this involves both what materials you're using, how much of that material you're using, what's the waste associated, to name a few. Also aiming at waste generation or material efficiency, we can create indicators of tons of material that are going in the process as raw materials versus how much of it is used in the final finished product. So as you see, some of these indicators are completely outside of the scope of 6G. So this is the use case KPIs, and this is indicating yes, whether it corresponds to one use case KPI or not. And this, as a reminder, are meant to describe the overall value that the use case is bringing. But then if we refer to the indicators that we can actually influence, we have, for example, the kilowatt hours per process or overall. So of course, there are many parts of this KVI that lie completely within the cobot's design, but we can also take into consideration the communication aspects of these robots and how can we deliver the communication between these two robots in the most energy efficient way. So we are currently working collaboratively with other work packages within Hexa to determine how these enabler KVIs can impact the 6G design or the enabler selection, and then to connect those learnings and requirements back into the use cases. I think I have 1 minute left, but as a closing comment or disclaimer, this process, as I've already mentioned, it's let's say a generic one, and it's definitely not exhaustive, because for it to be exhaustive, it needs to be applied in a real world situation. But rather, the idea for this, it tries to provide a guideline on the value creation to unlock many opportunities in the deployment of these future technologies. So that's on my side. Thank you for listening.
Thank you, Cristobal. Great. And as said, so please use the chat as the main channel. And there is one question also to you there. And then for the rest of the session this morning, we are hearing overviews towards 6G from different parts of the world, as well as then from vertical perspective. And in afternoon, we also continue that from North America at then a time that would be more suitable for them. But so then in the agenda, we would be going to the 6G overview from a Chinese perspective. And we had Shaohui already earlier before the start here in the call, but actually don't see you at the moment among the attendees. So can you hear us? Okay, now I can see you again. So I make you back a presenter. So please, the floor is yours.
Okay, thank you. Can I share my...
Yes, please.
Okay, let's see. There is my slide. Can you see my slide?
We can see them not in the presentation mode, but it is visible.
Okay, thank you, Chairman. Good morning, everyone. My name is Shaohui. Sorry.
Yeah, I muted the disturbance, so please continue.
Okay, thank you. My name is Shaohui from CICTMobile. On behalf of China MT 2013 Promotion Group, I will now introduce the 6G research process in China. The first slide is about how we understand the vision and the goals of the future 6G. As we are familiar with the 6 usage scenario of MT 2030, we believe these 6 usage scenarios will encompass key typical use cases, such as immersive cloud XR, holographic communication, digital twins, and global seamless coverage, among others. From the usage scenarios of the integrate of AI and communication, we aim to achieve the native AI designed and applied AI throughout every aspect of 6G network, making AI the foundational layers of 6G and offering AI as a services. For the integrated sensing and communication, ISAC, we hope to fully utilize the advantage of communication networks to provide diverse services such as communication, sensing, and positioning, thereby expanding 6G network application scenarios and improve communication efficiency. In terms of the ubiquitous access, we aim to achieve the space-ground integration in the futures, leave regions end-to-end to enable the broad and more cost-effective coverage for mobile communication network. Meanwhile, immersive broadband will further enhance the transmission rates and efficiency based on the 5G. For the industry in IoT, we hope that 6G can further enhance the industry production and operational efficiency. Next slide. Here we first introduce our perspective on the 6G network system. As our understanding, the 6G systems will evolve beyond the connectivity, expanding its function to include the computing, data, sensing, and AI will continue to depend on new capability for the 6G network. To achieve this goal, we should first to depend on network capabilities, include connections, which is based on 5G, optimize the existing systems and interfaces to support the business requirement in new scenarios. For the computing, which is collaborate with the connection functions to optimize the efficiency of the new services, such as AI. Data provide the data services capabilities for new 6G services scenario, such as AI and sensing. AI will provide AI services capability for the operations and maintenance of the network itself, as well as for the users and third parties. Sensing will collaborate with the connections functions to provide ASIC. Second, we aim to enhance the platform-based services architecture, reduce the types of network function, simplify the unity the interactions, and lower the OM cost. Enable faster suggestion of edge, the subnets, and plug and play functionality for new services. At the same time, we also need to depend the research on the 6G wireless architecture and the functionality to support the 6 usage scenarios of IMT 2030. The 6G round has the potential to become a multidimensional resource carrier for the communication, sensing, AI, computing, and data. By leveraging AI, we can create inflexible and simplified intelligent communication wireless network that support the diverse business requirements. Intelligent communication, we can say the AI for RAN. Utilizing AI, the technology to improve the network performance, efficiency, scalability, and intelligence levels. RAN for AI, it can flexibly and efficiently share the RAN side AI functions and the physical resources and enhance services performance through the UE edge cloud collaboration. In the left of the slides, there is an illustration of the integrated intelligent communication functions, where the 6G RAN is divided into the 3 layers. There is infrastructure layer. Second is the virtual resource layers, and from the function layers. The infrastructure layers provides fundamentals, software and hardware capabilities. The virtual resource layers virtualize the underlying resources to enable the first-grade resource management for different services. It supports dynamical resource management and orchestration, providing function support for the various up-layers services. The function layers focus on the connection, data, sensing, and the computing functionalities. Through the AI-driven resource orchestrations and scheduling, It ensures the optimal queues matching for the different services requirement. This slide introduces the 6G technology trials in China. Since the 2022, China has the trial is divided to the three phases. First is the key technology trials from 2022 to 2024. Second is technical schemed trial from the 2024 to 2026. And the last is system trials from the 2027 to 2029. Currently, the key technology trials phase has been complete. The key technology trials aim to promote the development of conceptual prototype in the key technology area, accelerate innovation, and foster consensus of technology standards. The IMT 2013 Promotion Group conducted tests on 9 technology in total. In 2022, 5 technologies were tested. It includes terahertz communication, integrated sensing and communication, reconfigurable intelligent services, mobile computing networks, and distributed autonomous networks. In 2023, 2 additional technology, wireless AI and data services were introduced. In last year, terahertz communication was removed, while the integrated satellite and terrestrial network and network architecture were added to the trial. Here we will provide a detailed introduction to the testing progress and related conclusions for some of the key technologies. Let's start with the ISAC. Before 2024, the focus was primarily on evaluating the performance of the prototypes with the monostack sensing and TDM-based ISAC. In last year, the testing expanded to include the new ISAC waveform, SDM-based ISAC, bistatical sensing, and ISAC networking. Based on the test results, the following preliminary conclusions can be drawn. First, one is for the waveform. A certain level of the consensus has been researched with focus on the off-DIM waveform and its enhancements. 2 is for the SDM-based ISAC. Initial verification suggestion that SDM horizontal beams can be used independent for the sensing or communication. 3 is for bistatical sensings. Preliminary test confirmed the synchronization requirements and the feasibility of the bistatical sensing. For the this slide for the wireless AI trials, previous tests demonstrated that the AI-based physical layer design focus on both the single models optimization and multi-modal joint optimization delivers the significant performance gains under complex channel conditions. In 2024, the trials primarily focus on the generalization enhancement and explored additional potential application scenario for the wireless intelligence. Based on the test, the following preliminary conclusions were drawn. One is AI-based physical layers multi-modals joint optimizations can improve performance by 10% to 18%. Second is the model fine-tunings combined with the hybrid data augmentations significantly enhance the generalization capabilities. Three is independent bilateral model trainings provides a 20% boost in the throughput with the even greater gains observed when the identical structure are used. For the trial results of the data services, previous trials primarily focus on the fundamental functions. In last year, the trials shift the focus to the collaboration between the data services functionality and the network functionality, as well as the efficiency of the new data services protocol. Key areas of testing include capability discovery and request identification, data services protocols and efficiency, on-demand data connection and data reuse. Based on this test, the following preliminary conclusions were drawn. First is the collaboration, the capability between the data services functionality and the network was successfully verified, leveraging the mobile network architecture and protocols. Second is in a simplified networking environment, protocols such as TCP, QUID, HTTP/3 and self-developed air interface data services protocols were used for the data services transmission. The trial demonstrated and evaluated the efficiency of data transmission used this protocol. For the trial results of the mobile computing network, previous trials primarily focus on the evaluating the capabilities of computing and the network awareness, droid control and scheduling, and service deployment. In 2024, the trials focus on the aligning physical computing and the network evaluation indicators, and exploring the collaborative scheduling capabilities of the UE agent cloud computing resources in the mobile networks. Key areas of testing include computing and the network indicators, user agent cloud collaborative computing, and services continually assured. Based on the test results, the following conclusion were drawn. First is the prototype can successfully identify the physical computing and the network indicator. Second is collaborative computing between the UE agent cloud has been preliminarily achieved. road the cooperation mechanisms still lacks flexibility. Third is some company has verified the collaborative capability of data computing and the network function for AI services. For the trial results of the network architecture, previous trials focus on the reaching a consensus on the distributed network, mobile computing network, and the data services. In last year, the key focus shifted to the verifying the functionality of 6G network architecture through a prototype. The technical solution include the preliminary realization of a basic network functionality, integrated control and scheduling of the multiple elements, distributed network capability, and trustworthy network functionality. Key area of testing include network functions, control and scheduling, distributed network, identity management. Based on the test results, the following preliminary conclusions are drawn. First is general consensus has been formed on the capability of the connectivity, computing, data, and AI element within the network architecture. The basic function and the scheduling process of these four elements has been preliminarily verified. Second is the capability for the integrated control and scheduling of the multiple elements has been preliminarily validated, though the further research is needed to enhance the collaboration among these elements. Third is distributed ledger was successfully used to implement the identity credential functionality, but the deployment of the blockchains varies across different scenarios. Finally, I will briefly introduce some of the research reports and white papers released by the MT 2030 promotion group in recent years. The group has published over 6 research reports and white papers covering a variety of the key topics. For example, in the area of the vision and requirement, more than 10 reports was released, include topics such as 6G use cases and security technology for integrated terrestrial and non-terrestrial network. In the area of system architecture, five reports was published, such as 6G wireless system architecture and functions. In the network technology and the security technology, over 20 reports was released. In the wireless technology, more than 30 research reports and white papers were published. Overall, the MT 2030 promotion group has been actively advancing the research on the key network technologies and the system design for 6G development. It has also conducted extension testing and verification of the critical technology. Through its research efforts, the group aimed to establish a technical framework for the intelligent connection of everything for 6G, and work collaboratively with the industry partners to drive the successful integration of 6G into the future mobile communication. Okay, that's the conclusion of my presentation. Thank you for your attention.
Thank you very much, Sun. So I don't see specific questions to you in the chat, but please use chat actively as you have been. There are also some comments there related to this, but not specific questions as far as I see. And as we are slightly late in the agenda, even though now it's a bit easier as we have the break coming, I would anyway propose that we start the break and take a break of 10 minutes. So hoping to see you back after this 10 minutes. And once more, thank you, Sun. Okay, so then we should be continuing our session and here additional geographic areas talking about 6G as well as the vertical perspective. Concerning the vertical perspective, we had the chair of 5G ICA from Bosch, Andreas Mueller, promising to join us, but Andreas, I cannot see you among the attendees. Okay, here you are. So just a moment. Yeah, just a moment so I can get you.
I'm here. Can you hear me, Mikko?
Yes, I can, but
Okay.
strangely in the alphabetical order at the place of M, I can't see you, and from this list that comes next to your logo, I cannot promote you as a presenter. So I don't know if my colleagues can help with this. But now I think you are a presenter. So yes, sorry about the glitch, and great that you could come. And please, the floor is yours, Andreas.
All right. Yeah. Thanks a lot, Mikko. Thanks for the kind invitation, and hello, everybody. So let me then see if it works. Yeah. So I'm Andreas Müller. My day job, I'm working with Bosch, but I will present on behalf of 5G ACIA, 5G Alliance for Connected Industries and Automation, and yeah, I have the pleasure to bring in the view from the vertical industries to this meeting. Of course, 5G ACIA is primarily focusing on the industrial domain, so manufacturing and related areas. But I believe some of our considerations and views are not too different, maybe from other verticals, at least from discussions that we are having. So we noticed that some things are already very well aligned here between the different verticals. And of course, verticals most likely will play still a very important role in 6G. Of course, we had a big vision already with 5G, and maybe we are not fully there yet, but it's progressing. We were maybe just a bit too optimistic regarding the timeline and so on of 5G in the verticals. With 6G, hopefully we can then build upon the evolution of 5G. And of course, that's still where the big potential is, right? So that's why verticals are very important. Okay, so and I will share some perspectives also for 5G ACIA. It's still early days for 6G. We are still very much looking into 5G to make sure we achieve there what we wanted to achieve, but we have some perspectives already on 6G as well. So just one slide about 5G ACIA in the hopefully unlikely case that you don't know us yet. So we have established 5G ACIA in 2018 as a joint initiative to bring the ICT industry together with the OT industry, the operational technology industry, specifically focusing on the manufacturing domain, and to drive and shape the developments towards industrial 5G at a time. And of course, in future, it might be industrial 6G then. We have 5 working groups, which you can see here. So from that, you can also get an impression what the topics are we're working on. Of course, we are looking very much into use cases, requirements. And this is, of course, a never-ending story because there are always then also new capabilities coming up, which may enable new use cases. Maybe we see the gaps that we still have, which may result in some new requirements. Ecosystem and regulatory framework. So this is also about monitoring the spectrum situation worldwide and certification aspects and things like this. Then system architecture integration is a lot about the integration of 5G and future 6G into existing infrastructures. And there are many different communication technologies in a factory today, like industrial Ethernet, time-sensitive networking, and so on. Right? And these different bits and pieces have to fit together. We are reaching out and engaging with other organizations, of course, which we are doing in Working Group 4. And we have industrial 5G in practice, which is targeting more towards the needs of the end users. So we have our testbed framework and things like this. Okay, so but it's just in a nutshell, 5G SRA, and now let's focus on the actual content. So here this slide basically shows the original vision when we started 5G SRA in 2018. Right, so the vision was and still is that we have the developments on the industrial side. Industry 4.0 is still a big topic. Also, this takes time. It's not something that happens from one day to another. It's all about increasing the flexibility and efficiency and so on of the factory of the future. And then we saw that 5G was coming up, and the general vision is to bring both developments together, to bring mobile technology into the factory in order to lift Industry 4.0 to the next level and to reach unprecedented levels of flexibility so that we can easily, for example, adjust the factory. Also efficiency, which is always the main target in manufacturing, to have a higher productivity, and also better ease of use, so to support the people working in the factory in an intuitive manner. And here novel assistance systems like augmented reality, extended reality, as an example, right, can certainly help. So this is how we started, and it's still valid today. At some point, maybe we have to add 6G here, right? Because with 6G, it would be the same thing, that also here, maybe the new capabilities that come in with 6G may help us in achieving and driving this major development, which is Industry 4.0. So in the last couple of years, I mean, many use cases have been analyzed and discussed. So this here gives an overview of some use case categories. So mobile communications, wireless communications always make sense when we have moving or rotating parts. If we have mobile devices, right, like intralogistics, so these automated guided vehicles, smart tools that are portable. But also then, human-machine interaction. I mentioned this already. Augmented reality, extended reality in general certainly also has great potential. Then also connecting wireless sensors and actuators, large areas that need to be covered. This holds, for example, very much in the process industry, where we have easily areas exceeding square kilometers, right, in the chemical industry, for instance, and it's a very challenging environment. So here is simply more cost efficient, maybe to have a wireless connectivity than to have cable connection. Then we have this flexibility vision, right? So that's why there are developments towards a highly modular production, a matrix production, for example, so that we can also easily rearrange the production facilities. Retrofitting, upgrading existing machines is very important. That can be more easily done if it's wireless communications that we're using. And this is also important because of the long lifetimes of the equipment in the factory, and also positioning and so on, right? It can also be done with mobile network, of course. Also, this has a promise of high value. There are other positioning solutions available, but convergence is also a key promise, right? So that we don't need to deploy and operate multiple systems at the same time, but the fewer, the better to some extent, and the more cost efficient ideally. So that's why also positioning and knowing where things are basically is always a very valuable information. So I think this is well understood, right? And the key message already is, I mean, we have analyzed and identified all these use cases, and these use cases are still valid today. So just because we have a new generation of mobile networks means that it will be completely different in a factory. Of course, all these things still matter, and we should always, on the one hand, still support the things that already can be supported with 5G, but also then see how can we maybe do things even better, and the new capabilities, right? How can they support and even enhance maybe these use cases that we have identified already? So don't have the ambition to get something completely new, but take what we already have and what is well understood in many cases, and then focus on evolving this, taking it to the next level. Also, then the requirements, of course, are very diverse. We have these diverse use cases that come along with diverse requirements, and it's not just performance requirements. That's, of course, the basis, right? And for many use cases already with 5G, we have rather demanding requirements. With 6G, maybe there are use cases that cannot be addressed with 5G yet. So it's always high reliability, availability, low latency. All this has been thoroughly discussed already during the 5G discussions. But we should also not forget there are then also more functional requirements, new functionalities that should support it. private networks or non-public networks, as they are typically called in 3GPP, right, are very important still, and they should be considered also the developments towards 6G from the very beginning. Also, time synchronization is another example, right? So it's we have a lot of closed-loop control systems in a factory. We need precise understanding and synchronization of time. And if this can be supported by the mobile network, that's good. Time-sensitive networking will play an important role for wired communication. We have introduced many building blocks with 5G already. Also, this remains an important aspect. And also then other things, yeah, positioning I mentioned already just as examples. And then on top of these functional requirements, we also have special operational requirements. So what is meant with this? So we have, hopefully private networks. And private network, of course, is a much smaller network than a public network. At the same time, we need a higher flexibility and versatility of these networks, right? Because maybe the factory changes, you produce a new product and so on, with the use cases change. So you need the flexibility in adjusting this, reconfiguring the network, and also the ease of use, because in many cases it will be enterprise IT people maybe dealing with the network, even if they rely on the assistance of a communication service provider. But having it simpler or more modular and so on. So also these are key requirements. So that's why we should also not just focus, right? Sometimes maybe we tend to do this on the KPIs with the hard user plane requirements, but also on the operational aspects and the functional requirements. And what is really a key request from the manufacturing industry is that it's evolutionary towards 6G. So this is important because now it took us quite some time to get started with industrial 5G. We are not there yet, but it's evolving. So certainly we are making progress. And if you now tell people, hey, and in a couple of years there will be 6G and you should forget all of what we've done with 5G, they will not like it, right? And investment security in general is very important. And this goes hand in hand also with the different life cycles that we still have. I mean, the ICT industry is very fast, right? And we have very short life cycles. It's also very much consumer driven still. It's very different in the industrial domain. And this needs to be aligned. It needs to be understood. I think there is now better and better understanding than when we started with industrial 5G. But both things are really key. So evolutionary development towards 6G and taking these different life cycles into account. And just to highlight this a little bit more, right? So I've here one slide to illustrate these life cycles a bit more in detail. 3GPP, most people you know very well, right? A new release, let's say every 18 months on average, sometimes a little bit longer. Then if you look at a smartphone, mobile phone, I checked the statistics and I found a value of 2.5 years as the average lifetime. Some maybe buy a new one every year, others maybe every 3 or 4 years. On average, 2.5 years. So really fast-paced, short cycles. In the OT industry, it's different, right? A new robot, average lifetime of a robot is maybe in the order of 10 years. If you look at the process industry, chemical industry, and so on, the equipment will be used for 20 years or even longer. And this is the challenge. This is one of the challenges also why industrial 5G still takes a bit more time. And of course, it's also a challenge now in the migration from 5G to 6G, right? So that's why we need this backwards compatibility. So we need this evolution towards 6G. And we also have to rethink maybe a little bit the way how things are working here, right? How can we do a better match? So something that has been discussed already, which was an idea at least, that maybe would be worthwhile to consider is also to do more multi-release planning. So not just to look always from one release to the next and to forget, I exaggerated a little bit, right, what has been done before, but to plan a little bit ahead, what may come and what is needed and so on. And then this gives also the OT side a bit better planning stability somehow and a better understanding of what is coming. So that's important to understand, but let's go a little bit to the more specific aspects, right? So what might 6G deliver and provide that 5G cannot do yet? Of course, there are some performance improvements, right, that could provide value. In 5G, we already discussed always the 1 millisecond latency, right, and the 5 nines or 6 nines communication service availability. And if we get this in practice, right, it still would probably cover many use cases. One of the problems is we don't have it in practice yet. So it's in the standard, but not really in the real world implementations. So this is something we have to think about, right? Are there maybe also different ways to realize this? So with a higher probability of already also getting implemented at the end of the day, maybe the current approach was a bit too sophisticated in a way or so. So I think this is something to be considered. So how can we make sure it finds its way into reality? At the same time, this 1 millisecond, I mean, it's somehow a good number, right? But for many industrial use cases, also 2 or 4 milliseconds would be good enough if it's dependable. Still, there are some use cases maybe where even, I mean, 1 millisecond or in some cases even below 1 millisecond would be needed. So if you have very tightly synchronized robots that should be collaborating, we also heard this in a previous presentation today, and things like this. Also, machine tools sometimes need latency cycle times below 1 millisecond. So there are such use cases, but it's not the majority of use cases. So that's why my personal view is it would be better to do things maybe in a different way from the way we've done it in the past, but to make sure it will be implemented at the end, rather than striving for even more demanding latencies and reliabilities. And at the end, again, nobody implements it. So then we cannot get any benefit of it. Anyway, so this, collaborating robots, AGVs, right, automated guided vehicles or autonomous mobile robots, bigger fleets than we had before and so on. So these certainly are still very relevant use cases. And also then the scalability in the terms, how many of these use cases can I support at the same time, right? It's maybe one thing to have a closed loop control system in a lab environment with one controller and one sensor, one actuator. But in a factory, it's densely packed, as you can see here, right? So there might be many of these running in parallel. And also this needs to be supported in a dependable manner. So also this is still a challenge somehow. Then we have
Sorry,
this
Andreas, just one, how are we doing with time? So can you finish in a couple of minutes?
Yeah, I have 5 minutes if my
great.
clock is right, and I will try to do so, yeah. But anyway, it will speed up. It's a good remark. So operational aspects, I mentioned this already, complexity should be reduced, right? So that maybe in some cases also enterprises can take care of this on their own if they want. Others might rely on communication service provider. Also this flexibility, modularity, right? Manufacturing is very diverse. Not everybody needs everything. So ideally you can just install and buy what you need, and what you don't need, you leave out. So we have this trend towards virtualization, softwareization, opening up the system. So that's might be beneficial and for the manufacturing industry, and also this advanced exposure capability. So exposing the functionalities to the user, also to enterprise users, and they have different requirements, right? From the telco industry again. Keep in mind that maybe they are then the IT guys in a company taking care of this, and not necessarily big departments of a mobile network operator. Right? But still, there is a need to have basic functionalities for monitoring the network, for diagnosing it, and things like this. So sustainability, of course, is also a key topic in manufacturing, independent of 5G or 6G. So what can we do here? Of course, if the system gets more energy efficient, that's good. So developments like ambient IoT, which is part of 5G Advanced, right, is very interesting. Also, because there's a lot of RFID in manufacturing today. So if this can get integrated into the system, then again, you have this convergence and a lot of additional value. Also, it's always good to have better energy efficiency of the network, of the devices. But there's also sustainability aspect, again, coming from the evolution, right, of the developments. So if we don't have to throw out all the equipment just because we migrate from 5G to 6G, but we can have a software update in the ideal case, right? And then we get 6G capabilities. Also, this is more sustainable at the end. So also this should not be forgotten. And the biggest impact maybe is more the enablement effect, right? So that we use the mobile network, the mobile technology to realize other things based on it, which might have a even bigger level, right? So like energy management in a factory and things like this. So, I mean, there's a lot of, most of the energy, for example, is consumed in the production machines and not necessarily the network. But we can use the network then to unlock potentials here. And also this is something that needs to be further understood. Yeah, non-public networks. I think I mentioned this already. That's why we'll keep this slide short. So certainly this should be considered from the very beginning, looking at the different deployment options that we have analyzed already as part of 5G. There's no black and white, not one option that is suitable for everybody. It should be simple, it should be flexible. And of course, the privacy and security concerns that enterprises have, especially manufacturing, because it's very sensitive and very critical data, are also important to consider. What also still remains very relevant is then the integration of the network with the existing technologies that we have. So industrial Ethernet solutions, I mentioned this already, and others, because this will not go away. So there will always be a lot of wired communication, especially. A lot of great work has been done with the 5G development. So we should continue this with 6G and further enhance it. TSN, for instance, deterministic communication in general, right? Also DetNet as a layer 3 technology, and the integration is very promising. Yeah, so to the other things I think I mentioned, exposure capabilities and so on, and the integration also in non-PGP networks in general. So what might be even a bit more interesting to this audience here is that the new capabilities that are being discussed, and one key capability certainly is integrated sensing and communication. So this is something we started discussing also at 5G SRA. We recently published a white paper looking into use cases and requirements, primary use cases for ISAC from the perspective of the industrial domain. And of course, there are many things that you could imagine, right? So to use a network in a factory to create a digital twin of the environment, also in conjunction with the industrial metaverse, which relies on digital twins at the end of the day, monitoring and maintenance, right? To maybe also see if there is a forklift that is not moving anymore or an HEV, so this can be detected and you can react. But also to replace other sensors that we have in place today. So also here again, convergence might be a big promise. There are many sensors in a factory, not just radar, also LiDAR, cameras, and so on. And if some of them can be replaced by the network that we will have anyway, so that's would be very cool, of course, and promising. But it needs to be further understood and explored, because that's also learning from 5G, right? We have really to have a good cost-benefit analysis. So I think 2 more slides. And I'm done. Native intelligence, also this has been touched also in the previous presentation. And we looked into China, for example, right? So of course, AI is a huge topic in manufacturing. In 5G, 6G, we have predictive maintenance, condition-based monitoring, all these things. And here, one promise could be that the 6G system supports this, again, by providing capabilities for model distribution, for data management, and things like this. So that maybe also not everything needs to be realized over the top. And of course, also then the usage of AI for optimizing the 6G system is promising again. So hand in hand with what I mentioned before, so that we have the need to have it simpler, ease of use, you know, this simple operation. Of course, here AI has a lot of potential as well. But also this is something that needs to be further analyzed and understood. Real-time digital twins is the same story. Digital twinning, I mean, originates from manufacturing to some extent. There's many activities going on, and we see also here a lot of potential. Potential, for example, if you have a digital twin of the network that can interact with digital twins of the use cases, right? You can have some joint optimization. The network itself might be better operated with digital twins. But also if we have massive digital twinning in the factory, we have certain requirements on the network, right? For example, more uplink traffic to get all the sensor data, do the digital twins and things like this. So that's why that's certainly a key topic as well, and especially if it's real-time capable, so that we have again this common understanding of time between the physical world and the digital world, and ideally also low latency communication with a lot of uplink traffic. So that's the basis then for many things that we see here. So to wrap up, the last slide. Don't forget the industrial 5G use cases. That's important to know. So that's the reference, the benchmark, and we should see how we can further evolve them and improve them. Investment security, evolutionary development is certainly key. We have these long life cycles that I've outlined. And of course, yeah, we should consider the industrial domain from the very beginning. I'm also very happy about the invitation today, and I'm also happy that there were some other industrial cases that have been mentioned before already. And yeah, let's build up on what we have done, the understanding that we have, and then we are on a good way to make industrial 6G hopefully a success. For 5G ACI, it's early days, but we are committed and interested, of course, in driving this, and also driving this together with the community and with all of you. And with that, thanks again, and Mikko, I hand it back to you.
Thanks a lot, Andreas. So important information for development of 6G and the wireless solutions. And due to shortage of time, let's continue the discussion in the chat and move right away then to the next presentation from Korean perspective. So Junhwan Lee, please, the floor is yours. Junhwan, you should now be a presenter. If there is problems with Junhwan Lee, and as we are a bit behind the schedule, so Mitch, could you present the Taiwanese perspective, and then we maybe come back to Korean perspective after that?
Mikko, hold on a second. Can you hear me?
Yes.
Okay.
And also the video was working, but now we lost the audio. Now you're muted back again. Now we can see the slides, not in the exactly the same mode maybe that you are targeting, but more in the presenter mode. But if it is challenging to change, let's move forward like this, but would also be great to hear you again. Unfortunately, it's still visible in the mode of that we would be presenting, but the slides can be seen, yes. But no audio back at the moment. Junhwan, can you get your audio back and present it in this way if not possible to change? I guess you know that at the moment we cannot see anything and cannot hear.
Sorry, Mikko cannot see my screen.
We can now see actually your screen,
Oh,
but not anymore.
sorry about that. 여기서
Now we can see the screen.
What about right now?
Yes, we can see the screen.
Okay, good. It's fine?
It is in the mode of how the presenter should be seeing it, but we can move forward.
This is fine right now.
I mean, now we can see it not in the presenter mode, but we can see the slide.
Okay, then let me start it, okay?
Yes, please.
Okay, so my talk is about 6G R&D status and plans in Korea, mostly from our research institute perspective, since ETRI is well representing Korean government R&D policies. And also, I believe that most of the contents that I'm presenting today has a fairly good alignment with the views from other major players in Korea, such as operators, vendors, and academia. I will start with nationwide 6G project in Korea. The first phase of 6G research on a national scale started in 2021 and will continue until the end of this year. This first phase of 6G research is centered around 6 technology themes, as shown here: performance, broadband, precision, 3D space, intelligence, and trust. I think this project are focusing on 2 key areas. One is utilizing very high frequency band, that is sub-terahertz band, for achieving a very high data rate with target peak data rate of 1 terabps. Another focus is so-called 3-dimensional spatial communication, expanding the coverage of wireless connectivity by utilizing satellite-based non-terrestrial networks. The second phase of 6G research started last April, which is a 5 years project. Most of the project in 6G phase 2 are targeting for the 6G commercialization, so that the key technology developed during 6G phase 1 are adapted and applied in 6G phase 2. This project shift focused to relatively low frequency band, that is the upper mid-band, emphasizing massive MIMO, Open RAN architecture, AI-powered communication, and energy-saving technology. Another important large-scale research project, which is starting soon this year, is LEO satellite communication. The project focuses on developing a complete low Earth orbit satellite communication system. It covers technologies for satellite payload, high throughput inter-satellite link, and advanced ground systems, including gateways and mobile terminals. Last year, it was under review, but it was approved in May, and it is set to begin soon this year following a public tendering process. The project will be compliant with 3GPP NTN specification, and Release 19 will be the first specification in this project. Back in 2023, the ITOR finalized the 6G framework, where we have 6G UC scenarios described by this wheel diagram. Regarding key capabilities, we have this kind of picture called a palette diagram with 15 capabilities. Different from 5G, the exact target values of some of the capabilities, such as peak data rate, user experience data rate, AI-related capability, and etc., have yet to be decided, and they are to be determined in the technical performance requirement phase around 2026. Here, I would like to pay attention to ubiquitous connectivity in UC scenario and coverage out of key capabilities. Related to the 6G UC scenarios, ubiquitous connectivity, we believe how to design 3D network with TN and NTN will become an important feature of 6G. As shown in this slide, designing 6G integrated TN and NTN networking protocols and 6G NTN radio transmission technologies. Of course, it is also key on the development of 6G LEO satellite payload component technologies. Key research areas include TN and NTN networking protocols, which is enabling a smooth integration of ground and satellite networks, including seamless handover between them. 6G NTN radio transmission technologies, which are addressing challenges posed by large distances and varying satellite speed. Robust satellite payload components, designed to withstand harsh space environment. As for the spectrum usage in 6G, first of all, we need more spectrum to support ever-increasing traffic demand. We basically support a multi-layered spectrum approach. High band for sensing and ultra capacity, upper mid-band for coverage and extreme capacity, mid-band for coverage and capacity, low band for extended coverage. Regarding the upper mid-band, there are 3 candidate frequency bands considered in Korea as shown here. To maximize data rates and capacity, we think we will need at least 400 megahertz in the upper mid-band. Furthermore, 6G is expected to adopt advanced duplex, such as in-band full duplex for improved spectral efficiency. Regarding the channel bandwidth for 7.125 to 8.4 gigahertz, the propagation characteristics are similar to those of 6.4.25 to 7.125 gigahertz band, and 100 megahertz is being discussed. Meanwhile, for 15 gigahertz band, the views of MNO, there favors 100 band, and manufacturers favors 200 band is somewhat different. However, for 15 gigahertz band, where the frequency characteristics looks almost same as 28 gigahertz band, there is a view on bandwidth up to 400 megahertz band. Therefore, channel bandwidth would be around 200 to 400 megahertz band. Regarding NTN in 6G phase 1, there are the 2 links of 3D spatial satellite communication and 3D spatial mobile communication. Fundamental researches on each link to tackle the issues likely to happen. The researchers are keen to achieve gigabit level broadband services. As an example, in 3D spatial mobile communication link, beamforming technology should be developed even in jittering environment where the small movement between entities such as GNODB and aerial vehicle degrades signal strength a lot. In addition, we are researching so-called dual steer, which is a technology for integrated TN and NTN multi-connectivity. ETRI is actively engaged in the standardization of dual steer technology, which is being carried out by 3GPP-SA. Now I describe our future research topics for 6G, mostly focusing on non-terrestrial parts. Note that these topics correspond to major R&D topics in the upcoming 6G NTN research in Korea. Specifically, the 6G LEO satellite communication system aims to design both the feeder link and service link, focusing on payload RF and antenna technologies, including multi-beam phased array antennas and beamforming, a modem and software for operation on the LEO onboard processor, which is called OBP, inter-satellite link ISL laser communication as well. So in this slide, the idea is to apply open LAN technology in TN to the area of NTN with respect to a low cost and high efficiency next generation open NTN technology, naming 3D Open RAN. During last year's conference in Open LAN Alliance, ETRI proposed a new research item related to non-terrestrial network based on Open LAN in collaboration with a total 10 organizations, including Korea's 3 major mobile network operators, Samsung Electronics, and 6 overseas academic and research institutions. The research item was officially approved by the NGRG Technical Oversight Committee of the Open LAN Alliance. And this agenda has a long way to go, but we are going to continuously identify and lead emerging issues on NTN. planning to launch a regenerative 6G IoT antenna satellite based on software-defined architecture in 2029. Extreme Doppler and long propagation delay are the issues to overcome. Meanwhile, we also consider NOMA as a multiple access technology for wide area satellite coverage and fast-moving LEO satellite. I would like to introduce LEO satellite-based integrated sensing and communication. We think we should handle interference issues in the ISAC communication environment. To the end, RSMA-based precoder and bistatic-based structure would be the good solution to overcome such critical challenges in a LEO ISAC. Finally, this is our plans for 6G POC demonstration this year. One is demonstration of ultra-high resolution immersive interactive service, where the wireless network aims for up to 200 gigabps data rate, while the wireline network targets ultra-low latency of under 5 milliseconds over the distance of 800 kilometers. Regarding 200 gigabps ultra broadband, in particular for this project, recently ETRI has successfully demonstrated the world first 200 gigabps class wireless link by using sub-terahertz frequency band, leveraging 10 gigahertz ultra wide bandwidth for data transmission. It successfully demonstrated a 200 gigabps class 6G wireless link for the first time in the world. The result will enable the provision of various next generation mobile communication services. The 6G mobile communication system technology developed by this research team utilized a multi-point transmission and reception wireless transmission technology. By showcasing ETRI's latest 6G technology at this year's MWC with video clip, we aim to actively demonstrate our leadership in the field to the global audience. Regarding gigabps level TNN NTN integrated ultra 3D coverage, another POC demonstration is called the gigabps level TNN NTN integration, involving terminals simultaneously communicating with a cellular-based station and a low Earth orbit satellite onboard OBP. For POC, we are planning to showcase gigabps level link performances for each link, and a data rate boosting technology like dual steer technology will be introduced, while a fast TNN NTN link will be emulated in this demonstration. Okay, this is all about my talk for today. Very sorry for delaying my presentation at the beginning of my presentation. Thank you so much for your attention. Thank you.
Thank you very much, Junhwan Lee, and great that you were able to also do it in a bit faster mode. And yes, sometimes we just have these glitches. But due to interest of time anyway, I would propose to continue the interaction in the chat and then move to Taiwanese perspective. So Mitch, the floor is yours.
Thank you, Mikko.
Great, we can hear you and see the slides. Or at least we were able to hear when you said thank you, Mitch, but after that we haven't heard. Still not possible to hear you, Mitch, even though we were able to hear this thank you that you started with.
Okay, can you hear me?
Yes.
Okay, now let me just, I think my headphone is quitting on me. Anyway, right, so can you see the slides as well?
Yes.
Okay, right. So thank you, Mikko, for this wonderful opportunities for me to share some progress in Taiwan. My name is Mitch Zheng. I'm the research consultant for ETRI. And last year I made a presentation, and then this year I provided further update on this one. This is the outline that I'm trying to show today, but I think this is pretty much you'll feel that flow when I talk about it. So I've shown this slide last year. This is like our ETRI view, and that's like after a couple of years of search on like how we migrate from 5G to 6G. So we kind of conclude that in the 6G, we actually want to build this intelligent, green, and sustainability to follow this UN SDG goals. So in this case, we want to build this intelligent, green, and open 6G network, and we're going to use it to connect the digital and physical world. So that's our objective last year. But then we run into some trouble last year in practice. That is, it's not a technology issue. That's mostly like when we go to the IMT 2030 projects, and then we want to go to this kind of focus on the verticals for 6G, right? Then we kind of say, okay, we can try it. But then the problem is that the world seems to try to do this kind of digital physical world connections. So you have this meta and the real world, and then we have cyber, and then we have physical. We try to kind of connect to get them to connect together. So in that case, it seems like there's a 6G deployment. The expectation is that you will have something that's very different than 5G. However, in the last year, our focus, at least like in the North Americas and also in Taiwan, has been like a focus on the verticals. So, for example, like in the last October, there was a 6G symposium in Washington, D.C. One of the topics we're talking about is that how do we ensure 6G transformation profitable, right? How do we ensure 6G transformation profitable? But then when the slide was there, the immediate people in the field is talking about, how about let's make sure the 5G transformation is profitable. So indeed, there's a kind of mismatch on that part. And fortunately, I started participating in the 5G ACIA for some time, and then thanks for Andreas, that so with those discussions, I got a better chance to talk to our OT partners and see how things, what they are looking for, and then what may be the trouble or what may be the things that make that the 5G take up is not as rapid as it should be. So through the process, I did learn a few things over there, and then today I'd like to thank Andreas to point out that all the use cases in 5G are still valid for 6G. So we're going to continue working on that part. And then in the 6G, at least from this year, one thing that I would like to encourage our members to kind of focus more is that this concept of immersive communications, right? Immersive communications. We know that in the 6G Open RAN and also things, we have new technologies, we have new networks, we have those things on the pipeline, and then try to be delivered by 2030. However, we really need some kind of like a useful and also maybe people can feel and sense. So in the use cases, so that they can relate it to this scenario, and hopefully this will form a new adoption or new interest for 6G. Having said that, we follow the 3GPP pipeline, so I don't think we need to invest more time on this one. But the idea is that we still want to make sure that the technologies are moving, right? The technology is moving, and then meanwhile, we also need to focus on the use cases and use scenarios. And for the technology part, in ETRI, we actually have several areas that I'd like to share today. One is this kind of so-called AI RAN, right? The AI RAN on the lower left corner. That become a subject for the evolution of the RAN. And then, so in the 3GPP, we have three focuses on position and CSI feedback, and also the beam management. And in ETRI, we decided we want to take on the beam prediction and the channel state information as the starting point, and then we focus on those parts, right? And then we also cover the RIS, and also we want to work on the FR3. The next area is AI for SMO, right? The service management and orchestration, right? And then this actually is based on the release 18's intent-driven management as defined in real R18, right? And over here, then we also try to introduce the AI element into this one. So the purpose is that you can use actually the operators can use a natural language as a base to actually use an LLM and then to kind of provide a better service management and orchestration work for their network. And regarding the 6G, we also focusing on prototyping, and then we already has a bunch of achievement on the RIS. And we actually, our ETRI team, my colleagues actually has successfully participate and joined this 6G sandbox project. And in the 6G sandbox risk force on the upper right corner here, we actually provide different kind of risks for the 6G sandbox project, and then including the glass risk, and then also with the pin dial risk, liquid crystal risk, and CMOS risk on that part. And then we also extend our collaboration with the 6G sandbox. I think we just joined the second phase project, and then we are going to have a live demo pretty soon in the sandbox test site. On the other hand, we also work with the MediaTek. We provided this FR3 antenna array, and then we try to get it to communicate for the NTN activity and the use cases. In addition to the industrial activities, then I would also like to share the development from the universities and R&Ds in activities in Taiwan. And there's another organization called the National Science Technology Council, and they actually lead the 6G project as well. There are 6 major universities participate in this project, and they all come from the different part of Taiwan. And we have a key technologies, including the sub-terahertz transceiver circuit systems. And then we also have a RISC-based FR3 and an open source B5G 6G core network. Then pretty much aligned with all the development in the world. Then we also have some kind of prototype platforms. And then the satellite, of course, that follow similar to like our colleagues in ETRI in Korea. So we actually also focus more on the satellite, especially on NTN, because we want to use it as a part of the secondary communication system, just in case like for example, the cables got broken in certain cases, that we still want to maintain the international communication capabilities. And then of course, AI is a big subject right now. So there are AI-enabled open RAN or core network. Those kind of activities going on, and then there's a hot subject as well. Then in their team, from the universities, we can see that this is actually a pretty busy slide because there are a lot of work going on, ranging from the integrated transceiver circuit for sub-terahertz communications, and then the RISC LEO is for these sub-terahertz. I will share this slide with everybody here, and then so after that, the Mikko and Patrik got a chance to post them down on the website, and you can find this with more details. So with those activities, so what's new in Taiwan right now, right? We found that over the past few years, we already have several research teams that put into this technology development. But now the question is that how do we turn the integrated use, and how do we know that those technologies we propose are valid, and how effectively we can use them, and better yet, how do we make sure that our end users has the capability and they're willing to accept those technologies? Let's pretty much try to address this matter, this issue, like how do we ensure 6G transformation is profitable, right? Then of course in the standard work we don't talk about profitability, but we can see that that kind of like a practical matter. For example, one of the obstacles or challenges for 5G is actually the complexity of the 5G system, especially when you're using it in the standalone fashion. Right? For those kind of parts that we cannot ignore it, because if we don't provide some kind of convincing or compelling reason for our OT partners, they will always be hesitant in taking up our technologies. So in ETRI, we already got a lot of research team going on, and then we try to create a campus-wide 6G trial network. The detailed size of the network we haven't really disclosed it yet, but you can expect that there will be like tens of the base stations, multiple tens of the base stations to cover this area, and then we will actually combine and connect all the labs, and then we want to make sure that all the technology are working, and also we will have the scenarios like regarding like when we do the for example, when we do the sensing, we want to know how accurate can this sensing can be done, right? And then we also try to use this as a key area for collaborations, because we understand that we do not own all the know-hows for all the technologies. On the other hand, if we build up this campus-wide trial network, we got a better chance to integrate or to work with other partners internationally. And then especially like, for example, on the network side, we are pretty strong in the O-RAN, Open RAN, and then also on the OTIC and TIC deployment over here in Taiwan. So we're going to take advantage of that part and then try to use this as a basis to invite all the international partners to have this joint project collaborations, right? At the end of the day, it will be like we will create something that's in the 6G, quote-unquote 6G environment, even though in reality, it may be based on the 5G network for now, but we will create those scenarios. And for example, what do we mean by immersive communications? And what kind of scenario and what kind of use cases can we demonstrate? Then those are the area that we want to work on this. So, which means that we were focusing not only on the technologies, but we also want to focus on the usage. So the international collaboration, we always follow this open gesture. So we already working with some potential partners, and also we already got some current international partners working on a different level. And then of course we always want to get it as a green and efficiency part. And then of course when AI introduced to the network, we always want to have a new intelligent. So either that's intelligent core network or intelligent RAN, and also maybe on the service level intelligence as well. So again, then we want to make sure that we have this 5G Open RAN ecosystem built up, and then we can have build up this in Taiwan. We offer a very good, trusted, and agile supply chain. So if you are interested in building this, using the technology and then turn it into industrial usage, we are a very good area in Taiwan. We can provide a very great environment for you to quickly turn your idea around. And then we also have this vertical applications, sandbox, everything we can try it. And then of course, we are seeking for the global partners, right? So that's pretty much what I try to cover today. And then I understand that I'm saying it at a very high level. However, ETRI, we actually have 8 different labs and also have multiple sites in the international, multiple presence in the internationally. And then we do have the resources and then to take on this. So we think that we want to not only talk the talk, but we also want to walk the walk, and we solicit your participation for the future collaboration. Thank you.
Thank you, Mitch, very much for the presentation as well as good management of time. But we are anyway, with respect to timetable at the phase, we should move to the last presentation. So thanks, Mitch, and please continue the interaction in the chat. And now we then welcome the perspective from India, and floor is yours, Professor Kuchi.
Have the slides here.
We can hear you and see you.
Okay, So let me share the screen.
Now
Is
the
it okay?
slides are, yes, please go ahead.
Thank you. I would like to set the context before we dive into our 6G activities. At the present time, there are 270 million subscribers, 5G subscribers, and the expectation is to reach 970 million subscribers, that is close to 1 billion subscribers, the 5G subscribers. And imagine billion subscribers consuming 66 gigabytes per month. That's the expected usage. So that's what 6G needs to deliver by 2030. The major application of 5G networks today has turned out to be fixed wireless access in India. The reason being, India has a different history. The wireline connectivity is not as high as compared to other regions. Therefore, cellular connection, rather wireless connection, is a substantial means to internet connectivity. So therefore, fixed wireless access is gaining a lot of popularity. So this has to be kept in mind to 6G evolution. India has been a good proponent of open and programmable networks, ORAN and its own evolutions. And there is a general expectation that 6G will be compliant to these open interfaces from day one. We have been embracing Open RAN kind of research, prototyping, and development. The government has funded many different consortia to develop Open RAN systems. And more recently, we have been developing advanced versions of Open RAN, including ULPI, massive MIMO radios, not only 32TR, but probably expansions of this into larger antenna arrays. So openness and programmability is expected to be a foundation for both FR1, FR2, and FR3 frequency bands going to the future. Moving on to the 6G IMD 2030 activity, India has made a strong pitch for inclusion of ubiquitous connectivity as a primary usage scenario. One of the main reasons for this type of connectivity push is that the topography in India is vastly different compared to other regions, in the sense that the number of people living in rural areas are more or less uniformly spread over a vast territory. We're talking about 700 million people or even more. So there is a need to offer connectivity with cell sizes ranging from a kilometer to 2-3 kilometers. When we say a cell, it doesn't mean a single base station. We're talking about terrestrial connectivity here. Of course, satellite can always be a complementary technology that is envisaged to be deployed in India. So with this motivation in mind, coverage, there is a new capability called coverage that has been introduced in IMD 2030, which did not exist in the past, along with the other wheel diagram is very familiar to most of you. So there is a need for coverage and especially both in urban and rural, larger coverage. I'll skip the envisaged applications outlined in the vision. I'll spare a moment on the ongoing national research activities funded by the government of India. There is a 6G communication system being developed at IIT Hyderabad, where I'm part of. The prime focus is 6.425 to 7.125 gigahertz frequency. And that has recently it's opened up by Indian government. It's going to be auctioned fairly, in the coming future. We expect to introduce a 6G prototype operating in this frequency band using a new waveform that offers higher energy efficiency and a longer range. The details of such testbed will become available in the next 2 quarters. Along with that, there is a lot of activity on using large antenna arrays, including something called a structural MIMO. It's more of a cooperation among antenna arrays and cell-free MIMO. These testbeds have been created, and a lot of experiments are ongoing. We continue to publish results in this space. Regarding Open RAN, the government R&D agency has created 2 consortia, A and B. Both are developing Open RAN compliant commercial base stations, and one of the consortia has started rolling out Open RAN base stations in a pre-commercial mode. Soon there will be deployments of Open RAN. These activities will naturally be upgraded to ULPI, FR3, and towards 6G. That's what we expect. On the terahertz side, there's a lot of funding that went into academia, and lots of different prototypes have been built, both in RIS and terahertz domain. On the SATCOM space, we have built some devices to support NTN. The device ecosystem is prototyping is ongoing. We will publish some of these results in the next few quarters. And we look forward to working with LEO and GEO constellations and the systems available to create the devices that are being developed at the present time. I'll dive into a bit of a technical aspects. There are 4 ingredients expected to be achieved, expected to achieve ubiquitous connectivity. The first and foremost is the power efficiency and energy efficiency of the waveform. A new waveform has been developed. We believe that usage of such a new waveform is not only applicable in uplink, but also in the downlink for offering better energy and power efficiency. This waveform is fully compatible with OFDM, and the details of such system will be made available in the coming months. There are already some publications made that describes the details of this waveform. As we have seen in the many previous presentations, large antenna arrays are expected to be play an important role in the coming years, and sectors, subsectors, centralized, distributed antenna arrays may be interconnected, and the base station baseband processors may apply centralized scheduling policies, including centralized cooperation among the antennas. This is something that is envisaged in the coming years. We have some results to demonstrate the usefulness in the FR3 band. There is also another expectation that, given the emphasis on coverage and large cells, I think it's very useful to have a chain of relays exploiting both mid-band and upper mid-band to expand the coverage. And of course, there will be a tight integration between terrestrial and NTN as a complementary means. I'll skip these details. This presentation will be made available. The structure of this new waveform is made available here. This has been prototyped, and a system has been developed, including this waveform. One of the advantages here is that in a single OFDM symbol, you can multiplex a reference signal and data what it really means is that it not only gives you low PAPR, you can reach operation at the clipping point of the PA. Not only that, you can multiplex users in the downlink. This is something new. We have developed large-scale prototypes, including antenna arrays with a large number of elements, and we've made some experiments, test beds. Not only the experiments and test beds, some simulation has been conducted. It appears that this is one of the test beds we built. It appears that the raw spectral efficiency, excluding the overheads, on the order of anywhere from 100 to 100 bits per second per hertz in 360 degrees can be achieved in the 6.425 to 7.125 gigahertz frequency band. Of course, such a gain is really realized by increasing the number of antenna elements as illustrated here, and the number of antenna panels that are assumed to be, for example, 12 to cover 360 degrees. So large-scale improvements in downlink spectral efficiency is feasible. Of course, there will be challenges with uplink. In general, this frequency band is of interest, and we continue to do experiments and build prototypes to evaluate the performance in the upper mid-band. So yeah, this is a bit of an involved slide, but the key point here is that I think a mix of FR1, 2, and even 3 using these relays it might be a good idea to expand the coverage, especially in remote areas where fiber is not available in all locations. I would like to summarize our views. Open interfaces considered an important ingredient in 6G, and interoperability across the various building blocks of the radio access network is considered essential. Ubiquitous connectivity without using NTN is an ask. The notion of ubiquitous connectivity is the terrestrial ubiquitous connectivity where there are people and there is this high enough density of the population. It is expected that there is terrestrial connectivity. Of course, satellite will have its own important role in achieving the so-called ubiquitous connectivity. 6.425 to 7.125 gigahertz is already made available in India, in the sense that a decision has been made that this frequency will be auctioned. So we are building test beds to evaluate the performance in this frequency. We have been building 6G base stations, including sensing capabilities. The test bed results will be available at the end of this year during the 6G study phase of the GPP. AI is considered as an important feature for the network, along with energy efficiency. And also, it is expected that narrowband IoT and Cat-M1 continues to exist, offering low bitrate IoT services, and 6G somehow ensures compatibility with this. Finally, fixed wireless access, a chain of relays using a mix of 5G and a 6G frequency bands are expected to offer both capacity and coverage. I will stop my presentation here. Thank you.
Thank you very much for the presentation. We have actually then, with also the good time management here, arrived at a situation where we are a couple of minutes before the scheduled ending time. And in the chat concerning the presentation here by you, Professor Kutsi, one aspect raising interest has been this new waveform. So if you can provide any additional pointers to material with respect to that new waveform, that would also be interesting. Or if you have something more to say about that.
Yeah, so what I will do is I'll share these slides and I'll give you links of the publications of this waveform. They are in archive. You can access the full paper related to the waveform. I'll say, I mean, I won't take more than 30 seconds on this. What we are offering here is a variation of DFT spread OFDM waveform. That is a foundation, which is anyway anyhow compatible to OFDM. However, there is something new that we have introduced. In a single OFDM symbol, any type of information can be transmitted either in downlink or uplink. All you need is a single OFDM symbol. Within this OFDM symbol, there are reference signals, there is data, and by using an appropriately selected spectrum shaping filter, it actually helps you to multiplex the reference signal and data in time domain, and you can achieve an ICIPS class of transmission with controlled pulse shaping. The primary purpose is to enable multiplexing of reference signal and data. The details are available where an exhaustive simulation and work has been carried out. This has been implemented in a test bed. Once this reference signal is made available, it gives you low PAPR in some when the modulation size is low. So you can achieve the peak power of the PA. That's a good feature. Therefore, in the downlink, you can transmit the signal at the saturation of the PA transmission and still enable multiplexing of multiple users in the downlink. So I will make one paper available. The other details will be made available at the 3GPP 6G workshop, where we have a complete 6G new radio specification, an outline of the specification, both for downlink and uplink based on this waveform. So I'll stop here. Yeah.
Yeah, thanks. Thank you for the clarification. If concerning any other presentations or any related discussion concerning today by anybody, maybe we have time for a comment also via audio. So please raise your hand. One thing that was, I think Mitch is raising his hand, and you have also in the chat a question, but please, Mitch.
Well, it's actually more like a comment rather than the question. It's like regarding in the early stage when we talk about a KVI, right? I just want to report that we do have some activities in the Next Generation Alliance, right? And then we try to publish this database for KPI, just KPI, not KVI. And then inside, I found that we have covered a lot of verticals. That can be a good complement for the Hexa-X work. So when it's ready to announce, which is probably March, April timeframe, I will contact you and also Patrik to make sure we share this with our colleagues in Hexa-X-II. Thank you.
Yeah, thank you, Mitch. And also, one question you had in the chat to Professor Kutsi was regarding the measure for ubiquitous connectivity. I don't know if you have any immediate comment to that.
Yeah, because actually, Kiran, it's good to see you again. And then you mentioned this ubiquitous connectivity. I understand that if I want to achieve immersive communications, I do need this as a basis, right? I make sure that the coverage is there and they're everywhere for those parts. But I also recognize that you maybe depends on different scenarios. For example, your indoor and outdoor. That may have different kind of measures. So I'm wondering, like, do you or your colleagues in India has started looking into okay, what do you mean by ubiquitous connectivity? What kind of a percentage of coverage is considered that, right? Thank you.
Yeah, thank you. So actually, our view actually is not about indoor, outdoor, because that's anyway is going to be solved at some point or the other in an urban setting, right? So you will find ubiquitous coverage as we go towards 2030, 35 in an urban area. So we're more concerned about when you move away from urban areas. There are large pockets of hamlets. They are distributed over a very large territory. This is very unlike other countries where 70% of the population live in urban centers, maybe 80%. But actually, it's not. It's quite opposite in India. There are about 500 million people, or even more, living in outside the. So what happens is that there is no fiber connectivity to every hamlet. So you have fiber connectivity maybe every 10 kilometers. So what do you do for the rest? So we have a peculiar situation. You have fiber connectivity to a group of hamlets, but then these hamlets are distributed with maybe 1 kilometer distance. So you need something else. That is, you have a fiber drop, and then you may want to cover a few, several kilometers with high speed. So this is what our notion of ubiquitous connectivity means. Where there are hamlets, you need connectivity, but there is not necessarily a fiber. Because in urban, we think that it will be solved by whatever means. But in this kind of peculiar situations, the cells are becoming smaller and smaller. That's not going to be very good for this situation. So that's why I was suggesting this hybrid network, a combination of FR1 and FR3, perhaps use a chain of relays, wireless relays, full-fledged relays. Maybe the one is 5G, the other is 6G, and you interconnect them, something like that. But the backhaul can be satellite. That's a different ubiquitous connectivity. Yeah, I'll stop.
Okay, great. Thank you. Yeah, good to see you again.
Okay. Thank you very much, and thank you all the presenters. Thank you all the audience for the live active interaction. And I think we are now closing the session, and there will be a continuation session starting in 1 hour from now with some new topics. But as said, so thank you for today and for this part. Bye.
Thank you.
Yeah, thank you all. Thank you.